Thank you, Kyle. And hello, everybody. I want to start by acknowledging all the presentations and the presenters today. It was a really great day for me. I'm really impressed by the quality of the presentations, and I'm certainly blown away by the solutions that have come forward. So I just want to congratulate all of you for all that you've accomplished at this point. I know how difficult it is trying to move a technology forward, so I appreciate your efforts. So my name is Jim Micak, spelled M-I-C-A-K. Okay, very similar to MICA. And I am the CEO of ElectroKinetic Solutions, and what I would like to do is introduce our tailings dewatering technology. I'm going to speak to four things today. I'm going to introduce the technology. I'm going to show you a video. I want to present some of the results of a pilot test that we conducted, which proved the performance of this technology. I want to share with you how we develop a business case for each and every one of our clients. And finally, I want to talk about the MICA project itself and what we're intending to do. So we have innovated a solution that uses the power of electrokinetics to increase water recovery, increase tailings storage capacity, reduce water treatment costs, and reduce liabilities. This is a video. It's 3 minutes long, and it will show you how this technology works.
The EKS technology is effective in treating a wide range of tailings from different mining operations. The technology can dewater active and inactive tailings facilities. The EKS technology involves a modular, self-contained system comprising pairs of anodes and cathodes, in-situ sensors, neutral buoyancy floats, pods of floating solar panels, and a control system that automatically regulates system operation. The EKS technology can be deployed at any stage during the life of a tailings storage facility, even after it is filled to capacity. By deploying the electrodes after a small amount of tailings have been deposited, the dewatering process can begin immediately and continuously, accelerating the consolidation process. The result is that the functional storage capacity is increased significantly. Pore water trapped in the tailings is continuously sucked to the surface by electroosmosis once power is applied. This dewatering action is assisted by gravity. The neutral buoyancy floats track the fall and rise of the mudline as the tailings are consolidated and fresh tailings are added. The electrodes follow the movement of the floats and are continuously and precisely repositioned in the tailings. As the tailings between the electrodes are dewatered, they sink due to their higher density. At the same time, fluid tailings flow in from the top and begin to undergo dewatering, creating a continuous downward flow of denser tailings. While dewatering is ongoing, electromigration reactions are also occurring. Negatively charged anions, such as chlorides and sulfates, are drawn downward. These anions become trapped deep in the tailings. At the same time, positively charged cations, such as heavy metals and scaling agents, are drawn up toward the surface. However, during the process, a strong pH gradient forms between the electrodes, with a high pH forming around the cathodes. When the cations encounter this high pH environment, many precipitate out of solution, becoming immobile and not escaping to the water cap. The end result is that these troublesome anions and cations remain entombed in the consolidated tailings. Once a tailings facility is filled to capacity, an impervious and geotechnically strong cap can be formed using the EKS technology. This cap prevents infiltration and effectively entombs the tailings. Reclamation can proceed immediately after operations cease. The final stage in the dewatering process involves removing the water cap and the floats. The electrodes are permanently embedded below the surface. A thin layer of soil is placed over the consolidated tailings. The tailings facility is now ready to be returned to a native ecosystem. Vegetation can grow and wildlife can return.
All right,
If you wish more information
can I get out of this?
on the EKS technology, please contact us at info@eks.ca or visit our website at www.eks.ca. Thank you.
Okay, gonna get out of here now. Can't get out, it's okay. Okay. I actually lost a few slides here, it seems. Just give me 1 second. This is the slide I wanted. Okay. We are a pre-commercial company right now. We are in conversations with several large global mining companies exploring and assessing this technology. One of the questions that we often run into when we talk to tailings company or tailings managers at these facilities is, well, show me this thing actually working somewhere. I want to see proof that this can actually work. One of our clients said, "You need to explain this magic to me. I don't believe it. I need to see it." And all I can show you and all I can show them is the results of a field demonstration that we did in 2019. We built a 20 by 25 by 6 meter pit at the Innotech research facility in Vegreville, Alberta. We filled that pit with 1,700 cubic meters of oil sands tailings, and as you heard, oil sands tailings are very difficult to treat. We operated that test for 19 months. The photo in the lower left-hand corner shows the operation. There's nothing to see. There is no operator. There are no moving parts. Everything that's happening is happening below the surface. And that surface happens to be about a meter of ice. When we completed the test and we pulled the water off, we saw that we had dropped the mud line by more than 3 meters. That creates an awful lot of capacity for future use in a tailings facility. We also, when we pulled the water off, we needed to get rid of that water. We went to the local municipality, Vegreville, and asked if we could discharge that material into the municipal sewer. They reviewed the water quality analysis. He said it's fine, and it was discharged into the sewer. And you can see in the bottom, in that photo at the bottom, that is the result of the treatment process. That brick is what is produced by this technology. I've spoken to some of the performance indicators. We were funded by CNRL, SDTC, Alberta Innovates, and Intercan, and they set the performance metrics. You can see the performance metrics they set in terms of the targets, and here's the result. We exceeded the performance metrics in each and every case by a considerable amount. The one that I'll draw to your attention is the energy consumption. This was the most challenging. One reason why ElectroKinetics has not been used for the management of tailings previously is because of the high energy consumption and the cost associated with that. We have solved that problem. And now that we use solar power to drive this, the cost of power to drive this system becomes virtually minimal. There are a number of economic benefits associated with the technology, obviously increased water recovery. This is extremely important for mining companies in arid areas. They're looking for water. They're piping in water from the Pacific Ocean up into the Andes in many cases. We can solve that problem. We can give them their water back for reuse. For every cubic meter of water that we recover or release, we create a cubic meter of capacity within that storage facility. So you can continue to deposit tailings as it's being treated. We can reduce water treatment costs because of the nature of the treatment process. You remove metals, you remove calcium, magnesium. We are now, like some of you in this room, we are now researching and exploring the possibility of recovery of some of these metals, and the initial research is very promising. we may be behind the curve based on what I've seen. And also this technology produces hydrogen, which can be captured and can be used at site. And there are a number of ESG benefits, and in many ways these are the mirror reflection of the economic benefits associated with the technology, and they're listed here. I'm not going to review them at this time. One of the things that we do, and we heard this morning, I think it was from Laura Lee, I hope I have that name correct, but we heard about the need to demonstrate the value of the technology to the mining operation. And what we do with each and every client when we sit down with them is that we develop a business case. We do it cooperatively with the companies. And what we do is that we identify all the benefits and all the costs associated with our technology and any competing technology, and we monetize the benefits, and we monetize the costs. And here's an example of a recent business case that we produced for a major mining company in South America. And you can see when you total up all of the potential benefits, there's over $500 million of total benefits. You back out the cost of our technology, the CapEx and the OpEx costs, and you have a net benefit of $138 million. Now, when you share that with the mining company, it's really quite amazing how that goes up the chain of command. And if you want to get attention from a mining company, this is the way to do it. It certainly has worked for us. So our next step now is, as I mentioned, we're pre-commercial. The remaining step in our path to commercialization is to prove the performance of this technology in an operating TSF. We need to show that we can deploy this the modular deployment of the technology. We have inflatable flotation systems that you saw in the animation. We have to confirm and demonstrate that we can actually deploy these and they can keep the system in place and that we can move them as required. And we have to confirm that the floating solar panels will provide sufficient power to drive the dewatering process. And for the MICA project, we've also identified a number of particular KPIs based on a treatment on a per hectare basis. So that's our technology. This is where we stand in terms of our commercialization of the technology. We're very appreciative of MICA and the funding provided by MICA. This funding is going to provide leverage for us in terms of bringing on board one of the 4 or 5 of the companies that we're dealing with right now and moving forward to that either small-scale demonstration or a significant pilot demonstration of this technology in an operating TSF. Thank you very much.